We're now going back to our first example where we took the two partials, we set them equal to 0, and we got a critical point, but we don't know if we have a critical point, whether it's a maximum or minimum or otherwise. Now we do have what's called the second derivative test. Now for the second derivative test, we need all four second derivatives. So here we go. I want fxx. fxx in this case is just 2. fxy. fxy is just 1. And then fyx. fyx is also just 1. That usually happens, that fxy equals fyx. And we also have fyy, and that's also 2. Remember how the second derivative test goes. It says, form a little matrix. Here we go. So fxx goes here, fxy goes here, fyx goes here, fyy goes here. Now normally we plug in the point, but there's nothing to plug into, and we're supposed to just take the determinant. You can tell that from the notation. What I'm going to get is 4 minus 1, and that's 3, which is positive. Now, the second derivative test says, start out with a critical point, take all the partial second derivatives, and then take the determinant. Now, if it's positive, what it's going to turn out to be is that it can either be a local max or local min. That's what the second derivative test says. If d is bigger than 0, then p can be a local max or min. Local max or a local min. Now, it does have a test for this, and I just want to discuss where that might come from. The idea is that this is fxx. Now, remember what fxx is from our interpretations of second derivatives. fxx says, take the section and look at the concavity. So this 2 here says, if we take a section and we're at a critical point and we look at the concavity, the section has to be concave up like that. Well, if you know you're either at a local max or a local min, and you take a section and you get something concave up, this is just like the second derivative test in Calc 1. P is going to be a local min here. Now recapping, we took the partial derivatives, we set them equal to 0, we made sure they're all defined, we got one critical point. The second derivative test then says, take all four second derivatives, make a little determinant out of it, and then plug in p. In this case, we got a determinant bigger than 0. Now, if the determinant's bigger than 0, according to the second derivative test, 2 things can happen. It can be a local max or a local min. So then it asks us to look at the sign. Well, either corner 1 will work, but let's just look at the corner 1 right there. That's fxx. fxx here is positive, which says that if we actually take a section at our max or min, we're going to get something concave up. Well, concave up means it's going to be a local min. And so that completes our first problem where we found a critical point and classified the critical point as a local min using the second derivative test.